In this video, we are going to talk about the nature of the data. And this is a very important issue to understand because it has important implications. Basically, if you understand the nature of the data, then you know what kind of questions you can answer. You know what type of model you can build, and you know what type of data collection approach you should use. So this very heavily depends on the nature of the data that you're dealing with. And you all know that we hear a lot about big data, and big data has definitely benefits. For example, Google search engine has a lot of data, and it gives very to the point recommendations, but it is not always about how much data we are collecting, because sometimes we are collecting a lot of data and a big portion of it is redundant. So it's about how much useful data we have. So it's not about big data, it's about big data versus smart data. And if you are to choose, a smart data is always the option to go for. So what are the type of the data we have? One type of data that we see a lot is the spreadsheet data. You, for example, get an Excel sheet containing the data that you need to process, you need to be model on, you need to analyze. And the type of data that you get on a spreadsheet form could be different. It could be numerical data. It could be, for example, the measurements from a patient record containing the blood pressure, blood glucose level. So these are all numerical data that you're getting at, and these are real values. It could be categorical data. For example, you have some images, typical example with cats and that, cats and dogs, and it is coming with labels, and it is categorical. It's either cat is or dog. So numbers basically represent a category in this type of the data. But we have another type of data that we call ordinal data, and it is coming sometimes in between. It has numerical value, but the numerical value has also an order. For example, if you're having a survey data and the respondents are supposed to rank the questions or the comments between 1 and 5, this these numbers not only represent a category, their order has also a meaning. So in a spreadsheet data, in short, we could get numerical data, real values. We could get categorical data, labels in a sense, and we could get ordinal data, which are discrete, but there's an order to it. But it's not always this clear cut. We could also get mixed data. For example, images are a good example of mixed data. They have the categories, but they also have tons of numerical data in their pixel data. So it is a mixed data of numerical values and categorical data. And there are a lot of data that we see in this form. It comes as a mixed data, and we need to know how to handle this type of the data. But it's not also always about the type of the data, whether it's numerical, categorical, ordinal, or mixed. It's also about the data dimension. We could have high dimensional data and we could have low dimensional data. High dimensional data could be images, for example. It has millions of pixels, or it could be low dimensional data. And for human beings, anything higher than 3 is actually high dimensional data. So one measurement of time series, running an experiment, short time patient record. For example, 20 patients with one measures in 3 hours every 10 minutes. It is all examples of low dimensional data that we could be dealing with. But keep it in mind that this high and low is pretty subjective. We don't have any standard definition saying that anything above that is high or anything below that is low. It is quite subjective. We also have another aspect of data types that we need to keep in mind, that is data label. And it has implication on what sort of models, machine learning algorithms you can use on them. The data could come labeled, as you see here. It could come, apple, cupcakes, this is clear. A new figure comes and the machine decides whether it's an apple or cupcake. There is no and we know the labels. This is actually where we used supervised learning. So keep in mind, if we have labeled data, supervised learning is the approach to go to. But data doesn't come always labeled. We also have unlabeled data. We could still get a data including apple, oranges, and mangoes, but we don't have any labels on them, and it is up to machine to cluster them. The machine doesn't necessarily give, and it won't give labels to the clusters, but you can see the similar things are clustered together, and this is called unsupervised learning. So we use when we have unlabeled data, we need to go for unsupervised learning. And another one is a data magnitude. It's not about dimension, it's about how many data points we have. How many examples do I have? Is it many or is it few? As I said, it's not about the dimension. For example, Google has many high dimensional images, but time series measuring 1 second may have low dimensions, and we could have huge data set with like not that many examples. For example, think about human genome data. It is a high dimensional data, but we have it only for a few people, and one reason could be that it's expensive to get the human genome for each individual. The data like this, that is high dimensional but for few example, is called deep data, and you need to keep in mind that it is not always about the dimension, it is also about the number of examples that you have. Another important feature that defines the nature of your data is a time attribute. Is it temporal data or it's not a temporal data? Do you have the dynamic describing the data? Is it correlated in time, or like pictures? For example, think about pictures and movies. They are all sets of pictures, but in movies there are time correlation. So there's a temporal aspect to the data you have when you're dealing with movie data, but in pictures you only have a collection of pictures and there is no time attribute there. So okay, we know the nature of the data. So what are the implications when we know that? There are several implications. First of all, it will enforce you to certain your data in a certain way, to store your data in a certain way. So how to store the data is another an implication of the nature of the data. How to process the data, what how to approach your data. This is also very important. And what machine learning approaches you could use. I mean, think about the labeled, unlabeled data. It is very decisive whether you use supervised learning or unsupervised learning, considering your data labels. What computational powers you need to use. I mean, when you have high dimensional data, very probably you can't really get meaningful result with low computational power. And another important thing is also what are the inputs and outputs. You get the data set, but it doesn't always come with a tag attached to it that we are going to use this input to predict that output. For example, you're getting a patient health record. You could decide to predict any of the features there as your output and then use the rest of your data as your input data set. So this is also another implication. You need to understand your data to know what input and what output you're going to define for your project. With this video, we conclude the videos in the first lecture of Introduction to Data Science course. In next week lectures, we are going go a bit deeper into how to get access to the data and get a hands-on experience on the topic. See you next week. Enjoy the videos and please post on forum any questions you have. Try to be active, help each other, and Let's enjoy the course together. See you next week.